This is a short overview of my low-power, Wi-Fi enabled security camera. The device was developed on a Raspberry Pi Zero W and interfaces with an Arduino Uno for some of the peripheral controls. The functioning principle of this device is to detect disturbances in the environment and then use image data from a camera to isolate events caused by humans and animals only. Let's get into a demo of the camera in action. As I enter the camera's field of view, a picture of me is quickly captured and processed. Thus, an intruder is detected, and the alert sequence will play on the lights. This time, as the swing of a door triggers the sensor, no humans will be detected in the frame. Thus, a simple reset sequence will play on the lights. The camera also works in low light conditions. This is done by use of a fill light upon initial detection of motion. Since a passive infrared sensor is used, random motion is also detected very well within low light conditions. Here you can see the four main external connections to the device. The use of two power supplies lets us power our development boards, camera, and sensors separately from our lights, allowing us to power up to about 130 LEDs on full brightness. Here's a view of the boards and peripherals without the box. The Type-B USB port on the Arduino lets it act as a Raspberry Pi slave, and this is very useful in delegating different tasks to be done on each board, and using serial comms to synchronize the timings of certain actions. All functions requiring internet connectivity and image storage are done on the Pi, while sensor measurements and LED control are done from the Arduino. I found that the Arduino was much better suited for the strict timing of the WS2812 LED drivers. These chips use the one-wire serial protocol, which can be bit-banged using port manipulation on the Arduino. A passive infrared sensor and photoresistor are embedded on the front face of the device. The PIR sensor is used to detect initial motion, turning the camera on only when needed. The photoresistor checks for low light conditions and toggles the white fill lights appropriately. Here's a closer look at the connections between the Arduino and the sensors. Aside from the light sequences on the LEDs, the device will also email you a picture when a person is detected. Here are the two pictures from our regular and low light tests. These images are processed using Google's Vision API. I chose to include some of the detected tags in the email sent to the user. I found it humorous that things like facial hair and fun were some of the more reliable markers of human presence. At least with my trials, that is. I hope this short overview has offered you some inspiration for your own IoT solutions, and thank you for watching.